what about the carbonates, except that sodium and potassium? They're not soluble. And there are few sulfates which are not soluble, right? Okay. Um, what is the reactivity series? Do you know the acronym? Superpower giraffe. Okay, because there is silver in between, like copper, silver, and then gold. Okay, okay. Let's. Mm, what can be done? Okay, we have this. Okay, did we discuss redox reactions? No, no. Okay, let's focus on redox then. Okay. And then we learned the reaction of metals with acids and water, right? What do they produce when they react with water? Metal oxide and hydrogen. Metal oxide, metal hydroxide. Okay. And what does it form when it reacts with acids? Metal oxide. No, let me write it. If sodium reacts with sulfuric acid, what does it form? Sodium sulfate and hydrogen. Okay. Um, then what is the main cause of rusting? In the air. Okay, let's discuss rusting in detail and the method of prevention. Though we have done like in general, we discuss how can rusting be prevented, how it can be prevented. Galvanizing, electroplating. Okay, so we are going to discuss these methods today. Okay, let's start with rusting. So we discussed that the main cause of rusting is air and water, right? Is my screen visible? I guess I haven't shared the screen. No, it's shared. Okay. Air and water. So what is basically what it actually form? So when they react, they form iron oxide, which is the rust layer, and it is red brown in color, and it can further oxidize the metal. No, the word is oxidize over here that we're going to use. So here the addition of oxygen is known as oxidation. Okay, because oxygen is added to iron. So iron is oxidized, and this reaction keep on happening, and the whole thing rusted out. So you might learn about the diagram whether rusting. Have you done the experiment on rusting? Like how can we investigate it? Okay, so there is a simple reaction that you can use. or simple investigation that can be used to detect the cause of rusting. So in the first test tube, you may put an air and water, and in the second you put only water, and in the third you only put air. Okay, so let's see what would be the result. If you put both air and water, the the nail would get rust. Okay, but if you put only water or only air, there won't be any rusting. Okay, now in the second test tube, if you look closely, uh, there is layer of oil on it. What is the purpose of putting layer of oil on it? To prevent oxygen to enter, to prevent air to enter. Okay, so it means only water is present, so alone it cannot do anything. It needs water as well as oxygen. Okay, then rust come as flakes. Have you ever seen rust? Okay, so it's a very flaky layer, and it comes in the form of flakes and keep on corroding or keep on rusting the iron. Okay, the best methods of the prevention for rusting is, the first one is to um, paint it or put a layer of oil on it, as we did in the second experiment. These are the common methods that we usually use. So, oh, where is the pen? Okay. First is we can coat it with paint. Okay. Yes. 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 Okay. Okay. So water is made up of two ions. One is hydrogen ion and other one is hydroxide ion. Okay. Okay. What else did I tell? Painting and oiling, or put a layer of oil on it so that it won't rust further on. So the corrosion would stop. Okay. And here in case of iron, as I've told earlier, that it's a ongoing process. If once it's started, you cannot stop it unless you put a layer on it. Okay, the second thing is the sacrificial protection. Now, what is that? Let me write it. Sacrificial protection. You put on some other metal on it. So in an in the reactivity series, which which metals are more reactive than iron? Whatever is before I, magnesium, okay, aluminum, zinc, right? These all are above the iron. So we can also done the electroplating. We can also do the electroplating for this one. Let me just paste it. Okay, this one is a reactivity series. So we can use zinc. Where's, we can use zinc. We can use aluminum for the electroplating of this substance. We just put on one layer on the another one to prevent the corrosion. The most commonly used method is to use zinc. Okay, why do we use zinc? Because it is more reactive than iron and it can replace iron. Okay, okay, and the plating of zinc is also known as galvanizing. There is a word for this, galvanizing. What is galvanizing? To put a layer of zinc on some other metal, for example, iron, and this is done by electroplating. Okay, now what is an electroplating? Electro means we use some kind of electricity or we use some kind of electric current to do this. So how what is electric current? Electric current is basically the flow of charges. Okay, so here we have a cell, let's say, and in cell we place the zinc electrodes. These are zinc electrodes. And here we have a solution. For example, we have zinc sulfate as an electrolyte. Electrolyte is a substance, or mostly it's a liquid that breaks down, or the ionized is in the ionized form, and we use the same electrolyte as the electrodes. If we have the electrodes made up of silver, then we have to use the silver electrolyte. It's maybe silver chloride or some other substance. Okay. Okay, now after this, uh, we just run run off the current through it, and the current would result in the electroplating of zinc over the iron. If here we have iron, let's say this one is iron, so zinc layer is going to be deposited onto the iron. So they have given an example of a ship. Like they are made up of iron, and because they are in water all the time, so they may corrode. So at that time we can use zinc to have a good covering over it, so that it won't be like rusted, and zinc would be deposited on it. Okay. Okay, now why do we use zinc? Okay, can zinc not be corroded? What can be the reaction of zinc when it come in the contact with air? So if zinc comes in contact with air, let's say zinc with air. So this air has two main factor. One is oxygen, other one is carbon dioxide. That we know, right? So it will result in the formation of zinc carbonate. Okay. Now this doesn't corrode to that extent, and it you can say it can make a protective layer on the iron, zinc carbonate. So this is known as sacrificial protection, like sacrifice is given by some other element. Okay, can you repeat it? What is sacrificial protection? What is sacrificial protection? Good. And what is galvanizing? How? Why do we use zinc? Good. Can zinc not corrode? So rather it forms a layer of zinc carbonate on iron to prevent the rusting. Okay. Okay. Next one. Um, Oxidation and reduction, or redox reactions. Okay. Redox itself is a combination of two words: reduction and oxidation. We have oxidation, and then we have reduction. Okay. Oxidation we have defined earlier. What is oxidation? The addition of oxygen. Exactly. Addition of oxygen is known as oxidation. So reduction would be opposite of it. Loss, exactly. Loss of oxygen is reduction. Now, mostly we use oxidation in terms of gaining and losing of electrons. So the gain of electron is actually the reduction, and the loss of electron is the oxidation. It's opposite. So it's gain of electron, and here we have loss of electron. Okay, the equation that we have written before, like if iron gets oxygen and it form Fe₂O₃, what type of reaction is this? Oxidation or reduction? Oxidation, good. It's a simple example. So let me give you a bit tough one. So for example, we have certain ions, let's say magnesium plus copper ion, and it gives copper plus magnesium ion. So what type of reaction is this? Since now we have to calculate, because the ions are given, whether there is loss of electron or there is gain of electron. Okay, so anything that exists independently or in elemental form has a zero oxidation state. Okay, so this magnesium would have a zero oxidation state. Similarly, this copper would have a zero oxidation state. While on the other hand, if you look at this copper ion, already the oxidation state is given, which is +2. And for magnesium ion, the oxidation state is given as +2 on the other side of equation. Okay, now if we look at the changes, this +2 is converting into 0, and the 0 is converting into +2. So what do you think? Which which atom is gaining electron and which one is losing electron? Good. Copper is so it's gaining electron while it's losing electron. So what would we say? The copper is reduced while magnesium oxidized. Is it so? So this is a simple oxidation. Now I'm giving you a bit tougher one. Let's have iron and copper sulfate, and it would be converted into iron sulfate, let's say, and copper. Now the charges are not given, right? Now we have to write the oxidation state or charges. Oxidation state is basically the charge. So this is the elemental form. It has a zero oxidation state. This copper is also in the elemental form, so it has a zero oxidation state, right? But what about this copper sulfate? Now they are in the, you can say, the chemical form or the molecular form or the compound form rather. Okay, and when they are in compound form, they have some kind of charge. So we know what is the charge on copper. Oh, sorry, what is the charge on sulfate? Not on copper, sulfate. Yeah, I've given you one, that table which has the charges. You can look at it in the chat and then tell. 2 minus. And let's talk about this copper and iron. The charge on copper would be, if it's 2 minus, then it would be +2, because there is nothing written over here. Then it means the both charges would be equal. If something is written in the bottom, that I'll give you an example. If something is written in the bottom, it means there is like some other charge. If none number is not written over here, it means they have same charge. Okay, I'll give you that example as well. Okay, now tell me which element is oxidized and which element is reduced. Okay, okay, and what will happen to copper? is from +2 to 0. Copper is reduced. So here copper sulfate is reduced while iron is oxidized. Okay, here we have gain of electron. Okay, I'm giving another one. What was I planning to give? The sodium plus calcium chloride gives sodium chloride and calcium. Can you write their oxidation states and then tell me what is reduced and what is oxidized? Okay. What about calcium and chlorine? Okay. So what is the oxidation state of calcium? It's in group number group 2. So it has an oxidation state of, what would be oxidation state of chlorine? Good. What over here? Okay. Okay. 0. Okay. Now, which element would be oxidized and which would be reduced? Sodium would be oxidized because it's losing electron, and calcium would be reduced. Okay. I have a similar example for you. KCl plus um, NaOH gives sorry. Oh, it should be oppositely written. Wait. Let me just write it. Mm, yeah. KOH plus HCl gives KCl plus H₂O. Is this a redox reaction? What are their oxidation states? Hydrogen is +1, chlorine is -1, this is also +1, -1, +1. Is there any change in the oxidation state? No. So this is not a redox reaction. Okay? Okay. Um, then let's discuss the magnification one. How not the magnification, how the extraction is done. We did one extraction in detail, the extraction in detail in our demo lesson. We did that, right?